Alright, so I'm gonna just go through every single method in the code. So first we have a swap method, and all that does is take two integers and swap them in the array. Then we have refresh list, and this is used because during the solving process I found that the list of pieces was not getting reloaded enough. So I made a method that would just reload all the pieces at once. Then we have, this is the initial state one. It's called start, like that. And then 1 through 6 represent the different colors. This is just the initial state of the cube, the solved state, before it's scrambled. Now we have the drawing methods, and basically just based on which color is there. So for example, if we have the color, then like if it's equal to 1, then return red, and then it's just going to make a square of that color at the x and y of that piece. Okay, then we go up to we go up to draw here, and all that does is just call draw top, then draw bottom all the way down. Then we get to the actual turning methods. We have R prime, which is just a counterclockwise turn of the right face, and it's just a bunch of swaps to get that to happen. Then R prime is called twice in R2, because if you think about it, two 90-degree counterclockwise turns makes one 180-degree turn. And then the same thing for R. 3 counterclockwise turns means 270 degrees, which is the same thing as positive 90. And it's the same thing for every other turn. And then we get up to the scramble method, which basically will take in a string, which will be passed in at the beginning of the run, and basically it goes through every single character, and it does the move based on that character. So if it sees an R, it'll do an R move, R prime, and so on like that. By the way, for counterclockwise moves, that is denoted by an apostrophe. Right there, you can see an apostrophe. And then 2s are just 2s like that. But Java won't accept the prime in the actual method name, so I had to name it R prime like that. Then we go to, this is the cross method. Okay, so basically what this will do is it goes through all of the edges, and it finds one that has white on it. And once it finds one with white on it, as you can see here, it says if it has, let me see. If s.getColor equals 6. So that means if it has white on it and it's not already solved, then we're going to do a set of moves where we take it to the yellow face, turn it so that it's under its correct face, and then we do the set of moves to get it into the correct spot on the white face, and it does it for every single piece. Then we come up here to the white corners, the bottom corners method, and what that will do is it does the same thing. Basically, it finds a piece with white in it, and then it'll go find the correct spot that it needs to go to, and then keep on executing the algorithm until it gets into the correct spot. Next, we move on to the middle layer edges algorithm. What this will do is it goes and finds one that does not have white and also does not have yellow. So if we see here, it says if it has 6 or it has 3, or it is solved, then it does not need a solve, and then only if it needs a solve will it go into there. So basically, if it went into this if statement, meaning it had white, it had yellow, or it was solved, then it's not going to go into this if statement. So basically, it's this is just will find all of the middle layer edges. Now, because we've already done the cross, we are assured that it's going to be in the middle layer. The edge we're talking about is already in the middle layer, or it's in the bottom layer. So now we can say this is if it's in the middle layer, and then it does a set of moves to get it down into the bottom layer. Or if it was in the bottom layer already, so if it started and ended in the bottom layer, so the face was never assigned, then we do a different set of moves. Then we find the face that it needs to go to, and then we do another set of moves to get it into the correct slot. Okay. This is taking a long time. Anyway, next set is the top cross right here. What this will do is, because we know that all of the yellow edges are still in the top face because we haven't messed with that yet, we have to go count how many are, first here we count how many are not already yellow, like how many yellow are not facing upward. And then afterward, if it's yellow, if it's 0, the number of non-yellows, then that means that the yellow cross is already solved and we don't have to do anything. If it's 4, then there's only one case where all 4 of the edges are messed up. So then it's going to do a set of moves, which gets it down to 2. So that's why we set count non-yellows to 2 again. And then we do this algorithm, which will solve that. Then after that, we go to the last part of OLL, orienting, which is top face. And basically what that is going to do is basically the same thing, just with corners. Oh my god, sorry, I'm recovering for a sickness and I forgot to take decongestants this morning. Edge turns is basically a helper method to the permutation of the top edges. It basically counts how many turns each edge in the top layer needs to make to get to their correct spot. So for example, if the color is 1 and the center it's over is also 1, then it doesn't need to do anything, so it's 0, and so on like that. Is solved just calls edge turns and then checks if they're all 0, that it can say that they're all solved. Now, top edges will get the number of turns by doing this, and then it'll go through. Now this is an important note. Count solved will never equal 3, because if 3 edges are solved, by definition the last one is also solved. So we want to get it to the point where only 1 is solved. That way we can cycle the remaining 3. That's the easiest way to do it. So if it's 2 or 0, there are a couple of cases. Either it's a really annoying case called a Z-perm, where 2 edges need to switch with each other, and another 2 have to switch with each other, and both are adjacent. It's kind of hard to explain, but basically it's gonna go and do this algorithm and then go back and then try it again. But basically over time it's gonna solve all of the edges by doing these moves. Then we go to the last step, top corners, which is which is just going to go and basically do the same thing for the corners, except now we since we know the edges are solved, there are only a handful of cases that are left, which is either one corner is solved, all of them are solved, or none of them are solved. So, right, see, either 0, 1, or 4 are solved. And here, if only 1 is solved, count solved equals 1. Then we're cycling the remaining 3, and it's going to solve it. So it looks at which piece is solved, and then it does a certain cycle. However, if it's 4, that means it's going to be if it's 0, right, then that means it's already solved, so we don't have to do anything. But if count solved is, if count solved is 4, then it's already solved and we don't have to do anything. But if it's 0, then we have to do a move called an E-perm, which is basically like this, and then we do another one, because an H-perm, which is when the corners have to switch with their opposites, it's just 2 E-perms in a row. And basically after that we have the cube, because if it's 4 we don't need to worry anymore. And basically after this the cube will solve itself. So now I'm going to show you an example of it solving. Well, solve just calls each method one by one and prints out the solution, and the main just calls scramble and the solve. So here I'm gonna go to I go to CS timer, right, and I collect a scramble that's auto-generated by a random computer somewhere. If I run this program now, it asks me to put in a scramble, so now I can just paste the scramble in. And now, okay, that's the auto-generated scramble, and then it does the cross like that. And then it does the white face like that, so as you can see all of those are the same. Then it does a middle layer like that. And then it should do these pieces. Yeah, there you go. It was gonna solve the white yellow face, and then it solved those edges, and then it just did the H-perm, which is when this piece, for example, needed to switch with this piece. I don't know if it shows up in the video, but basically, yeah, that's how you solve the cube. And then if you go here, if I just expand that a little bit, it says that's the scramble that we inputted, and then that's the white cross's solution, that's the white corner's solution, that's the middle layer edge's solution. The yellow cross doesn't have anything outputted because the yellow cross was already solved, so it didn't need to output anything. Then to get the yellow face, it did that. And then to get the permutation of the last layers, it just did 2 D moves, and then the permutation of the last layer corners like that. And that's a solved cube.